Hello friends, Namaskar. In this lecture, we will discuss about modified atmosphere packaging of horticultural and plantation crop produces. Okay. Here, we will study the modified atmosphere packaging methods and systems, its advantages and disadvantages, requirements of the packaging, use of modified atmosphere packaging of fresh produce packing, and its effect on nutritional quality, and finally, we will also discuss something about equilibrium humidity packaging. So, let us see what is modified atmosphere packaging. It may be simply defined as a packaging of a product in atmosphere that is different from air. From the name itself you can guess that is here the atmosphere around the produce, around fruit and vegetable inside the package is modified, and due to its substantial self life extending effect, it is considered as innovative approach, and it has having a very good requirement it is in the food sector. It is a growth innovative growth area in the food sector. Modified atmosphere packaging involves, as I told you, modification of the head space gases in a package, and which reduces this modification of gases reduces the ongoing biological and physiological processes around the food. It has the potential to increase the shelf life of fresh produce. Composition of the air surrounding the produce in the package is modified mainly to reduce the rate of respiration and other associated processes, and it is commonly used for even cut fruits and vegetable packaging or even whole fruits and vegetables. So, principle of modified atmosphere packaging, that is here MAP, basically as I told you, it balances the oxygen permeability with the vegetable's respiration rate. Okay. You can see here that is a fresh produce. Okay. So, when it is some sort of permeable material, semi permeable material is used, and with the help of that which selectively allows in and out of the gases, okay, O2, CO2 and even water vapor, and therefore, it maintains a proper desired level of composition of these gases, that is the oxygen, carbon dioxide and nitrogen content are controlled and regulated inside the packet, and this is achieved by modifying the film with its permeability limit depending upon the type of the produce, because different produces might they have different rates of respiration, their requirement for O2, CO2 etc. might be different, which we will see little later. However, it is very important to control, as in the earlier cases, here also it is important to control, to select the proper conditions of O2, CO2 etc. all right, and there should be proper balance between the humidity inside the packet and outside the package. So, obviously the fruit or vegetables, after it is harvested, it is subjected to the usual pre-treatment, pre-process of cleaning, washing, grading, sorting etc., then packing, and then here in the packaging, the modified atmosphere packaging, along with the packing, the arrangement for modifying the atmosphere is done, and I will tell little later how it is done, and then finally these packages are stored. Okay. So, in the earlier class, I hope you remember we had seen that when we discussing about the respiration, okay, that respiration process, transpiration etc., we had discussed, just to refresh your memory, that these fruits, vegetables etc., they continuously respire even after they are harvested, okay, and in the respiration they take oxygen, okay, and oxygen is consumed, and then carbon dioxide gas is released. Okay. So, if we want that in the cold storage or in the modified atmosphere storage or packaging etc., here by the level of O2 and CO2 is maintained in such a way that the fruit and vegetable respires continuously, but as slow as possible, because if the and when it is respiring aerobically, till it is good, but if aerobic respiration stops, anaerobic respiration will take over and the fruit or vegetable will spoil. So, here in all these, whether it is modified atmosphere packaging, edible coating, active packaging, or later we will see controlled atmosphere storage. So, in all these methods, basically we are controlling the rate of respiration, extending the shelf life, and rate of respiration is also related to the ethylene production. You can see its behavior, respiratory behavior in the climatic fruit and non-climatic fruit, it varies, and all these considerations are appropriately considered. All these factors are considered appropriately and process parameters are accordingly selected. So, different commodities have different metabolic activities, therefore, different respiration rates. So, a proper combination of oxygen, carbon dioxide should be maintained in the package for allowing commodity to respire aerobically at a minimum possible rate, as I told you. Okay. So, optimum O2 CO2 concentration differ for different commodity, even a same variety, same commodity, suppose you say apple or such other commodity, its different varieties might require different level of oxygen and carbon dioxide concentration for proper shelf life extension, okay, for proper maintenance of respiratory activity. So, the attainment of head space composition at optimum level led to lower deterioration of food produce with the time, and you can see here that is MAP and not MAP. Not MAP, the condition the respiration rate is very high. So, obviously, that is it is slowly it has a shelf life less, it is spoiled early, whereas when there is MP, modified atmosphere, then this respiration rate is slowed down and its shelf life is increased, and the reduction in the deterioration of the produce, it can be even 30 to 40% by MAP. That as a result, the shelf life of the produce gets significantly increased. You can see here in this figure. Okay. The tolerance level in this table I have given, that is the means in the modified atmosphere, and in this here level of oxygen is generally lowered down and carbon dioxide content is increased, and a proper balance between O2 and CO2 is maintained. So, the minimum O2 tolerated tolerance limit etc. for selected fruits are that maybe 0.5, tree nuts and dried fruits, some cultivars of apples and pear 1% is the minimum tolerance, and most cultivars of apple, pear, apricot, cherry, kiwi fruit, then peach, pineapple, plum, papaya, strawberry etc. 2%, avocado and primsum and the 3%, and citrus fruit and mango it is 5% is the minimum oxygen tolerable limit. Maximum carbon dioxide tolerated, that is apples, apricot, grape, olive, pear etc., they can tolerate 2%. Then apple, some cultivars, peach, plum, kiwi fruit, banana, mango and papaya 5%. Grapefruit, lime, lemon, then primsum and pineapple 10%, strawberry, raspberry, blackberry and cherry up to 15%. So, that is the in this modified atmosphere where these commodities are accordingly, that is the minimum O2 and maximum CO2 should be maintained accordingly, selected accordingly. So, different methods or technologies for modified atmosphere, types of modified atmosphere packaging are like active modified atmosphere packaging, passive modified atmosphere packaging, gas incorporation during packaging, or vacuum packaging. In fact, vacuum packaging is also a type of modified atmosphere packaging where oxygen is completely removed, okay, or sometimes nitrogen flushing is used where gas incorporation during packaging. Okay. So, active modified atmosphere packaging. Okay. Here the atmosphere is modified by creating a slight vacuum and replacing the packaging atmosphere within the desired gas mixture. And active packaging, intelligent packaging we studied in the earlier class. So, so here basically it is modification of the atmosphere is done actively by either use of oxygen absorber, carbon dioxide absorber, ethanol absorber. So, some absorbers, emitters or scavengers etc. are used, so that wherever desired either O2, CO2, carbon dioxide etc., their composition is maintained very fast, quickly. That is the active modified atmosphere. Whereas in the case of passive modified atmosphere packaging, here modification is achieved by general respiration of the commodity within the package. No scavenger, no emitters etc. are added here. So, the degree of modification here depends on the characteristics of the commodity and the packaging film. Steady state equilibrium is achieved when O2 consumption equals to O2 diffusion into package and carbon dioxide production equals to carbon dioxide diffusion out of the package. So, the kind of equilibrium can be maintained through use of proper packaging material with required permeability to respect gases. So, the commodity will be safe till this equilibrium is maintained. Okay. So, generally passive modified atmosphere, it takes some time for the maintenance of the desired O2, CO2 level or nitrogen level inside the environment. So, you can see that here the relative changes in O2 and CO2 concentration in active and passive atmosphere. So, in the figure here it is a cabbage, there is a normal packaging, active modified atmosphere packaging and passive modified atmosphere packaging, day 0, day 3 and day 7. You can see how the changes are taking place, but when there is active modified atmosphere packaging, means in this case scavengers or emitters etc. are used, scrubbers etc. are used. So, here this atmosphere, desired atmosphere is achieved at a faster rate. So, even third day also you can see, even 7th day also its condition is good, but in the passive atmosphere it takes some time. The same thing here you can see in the figure, that in the passive modification that carbon dioxide concentration etc. slowly, that is first it increases and then also you are not getting that sharp steady state, whereas the active modification, okay, that you get after it has the environment has been achieved, it is constant and it has been achieved quickly. Okay, the O2 concentration is progressively decreasing and CO2 concentration increase in the case of passive modification, whereas in the active modification the CO2 concentration is made almost stable, but O2 concentration is progressively decreased. So, that is the advantage benefits of the difference in the active and passive MAP. So, now gas incorporation during the packaging, that is the flushing with the mixture of gases. Air inside the packet is replaced with inert gas nitrogen, because in some cases it is seen even a small amount of air in certain materials like in the coffee etc., coffee powder, that may have some effect, it may oxidize. So, now there is a trend that this oxygen is totally replaced with the nitrogen or mixture of nitrogen carbon dioxide before packaging and sealing in barrier property. So, the material is filled into the package, placing in the chamber, okay, closing, then vacuuming, that is it is evacuated air etc., oxygen is completely removed, then gas injection, nitrogen flushing is done or other nitrogen CO2 sealing, releasing the vacuum opening, and finally you get the modified atmosphere packaging. Okay. Then vacuum packaging, it is as simple, it is very common, that is it is a kept air is mechanically removed from the package before it is sealed. Okay. So, once it is sealed inside, the air is completely eliminated and then the material is kept for some time. However, it will have some limitation, because see the packaging material etc. is used in such a way that it allows some variation, otherwise respiration rate may completely be. So, this is mostly suitable for those material where the respiration is not a problem or not a significant factor, their vacuum can be done. Processed products also. So, modified atmosphere gases, normally the gases used in the different combinations according to the product and the need of the manufacturer and consumers, and the gases are, they told you, oxygen, nitrogen and carbon dioxide. So, the choice of a particular combination, what should be the label of O2 CO2, that is normally typical combination is O2 in the range of 3 to 5%, CO2 in the range of 3 to 5% and nitrogen in the range of 85 to 95%. But within this range, what should be a particular composition of O2 CO2 and nitrogen, that depends upon the ongoing biological processes, sensitivity of the produce to gases, color stability requirement and softening of fruits and vegetables, texture, that is when you are changing the composition of the gases, how it is influencing the texture of the food. The considerations are modified atmosphere packaging of fruits and vegetables. As I told you, respiration rate can be reduced by decreasing the O2 concentration around the fresh produce, that is, but what should be the label, how it should, there are its effect on the enzymes like pectin esterases, polygalacturinases, polyphenol oxidase, glycolic acid oxidase or ascorbic acid oxidase. These are the important enzymes which are active on this, and many of these they continue because of the continuation of the life in the fruit and physiological process, respiratory behavior. Then similarly, how it is going to the change of the composition of the gaseous composition, how it is affecting the ethylene production rate, because ethylene is a ripening hormone and it is required, that is whether you want the blockage of synthesis of the ethylene which controls the activities of these enzymes, etc. So, all these factors are considered while selecting or while going for MAP packaging. So, factors influencing the effectiveness of gas include original and final concentrations of the gases, stage of maturity of commodity, types of product being packaged, water activity, bacterial population, partial pressure of carbon dioxide, storage temperature and of course, ongoing biological process. So, these are the factors which should all be considered while going for MAP. So, MAP of course, it has some advantage, but also it has some disadvantages. So, we will discuss first the advantages of MAP, that is number one, the product packaging. You can get a clear all round visibility of the product and it improves the product characteristics, it improves the shelf life of the product, okay, it improves the value of the product, okay, product quality, overall high quality product and shelf life increases from 40 to even 40 to 50 to 400% in some cases, depending upon the produce and the condition that are maintained. Then a special feature, that is sometimes use of some chemical preservative, etc., can be minimized by using a modified atmosphere. So, undesirable, that is the environmental pollution, etc., can be taken care of by having a proper modified atmosphere packaging and other materials. Economics also, it improves shelf life, results in the less financial losses. It may increase the availability of the produce and it may help in stabilization of the prices of the commodity, better utilization of storage space and equipment, etc. As far as the disadvantage is concerned, the product packaging, there is a increased package volume leads to poor retail display and added transport cost, etc. Okay. Benefits of MAP are lost upon package leakage. If there is even minute leakage, then the composition of gas will change and whole purpose will be defeated. Then product quality, that is product safety is yet not fully established in the case of modified atmosphere, because no heat is there and this how the participating microorganisms, etc., if there are any, so they may act. So, the safety is again is not fully established. Then temperature control is required, different products need different gas composition and this becomes a complicated material, that is one time only one specific commodity can be stored, special equipment and training is required. The economics, to maintain to analyze the composition of the gases, etc., gaseous composition inside the environment, within the fruit, inside the package, etc., and this needs high end equipment, etc. Even cost of gas filling and other machinery and their maintenance, etc. It may have some effect on the product cost and economics, etc. Okay. Then system for gas packaging, that is even horizontal form fill and seal machine, FFS machines for rigid and semi-rigid packages like deep draw machines, or horizontal and vertical FFS machines for flexible pillow pack pouches, flow pack machines, or vacuum chamber machines. So these are, in the earlier classes we had discussed about these machines, etc. So they can be used for modified atmosphere gas packaging as well. Okay. Even gamela, that these machines can be used for packing fruits, vegetables, salad, ready meals, etc. Even fiber lamp system, this can also be applied on fruit, vegetable. Bag in carton system, these are used for making consumer size packs of dry powders and granules such as coffee, tea, dried potato powder, or bag in box system. This is the advantage that a conventional unit pack can be produced and then gas is flushed. Requirement of the packaging material, that is yes, integrity of sealing, very important aspect. It is important to maintain the correct atmosphere in packaging inside the package. Then type of package, whether you are going for rigid or semi-rigid packet, lidded tray or flexible film pouch, these help in choosing the packaging materials. Even fogging, that is polyethylene in packaging laminates can be specially treated to prevent condensation of water that fogs the package and affects visibility inside the product, visibility of inside product. Microwavability of the packaging materials, like important factor, it is one of the important factor to be considered in gas packaging, particularly in case of RTE products, etc. Then biodegradability and recyclability, very important. A major challenge for the materials manufacturer is the natural hydrophobic behavior of many of the bio-based polymers. Then thermal and mechanical properties, the mechanical properties in terms of modulus and stiffness should not be very different to those of the from the conventional polymers, etc. So even compostability, the compostability is highly dependent on the type and composition of the material. So these materials should be used that, so that even environmental problem or disposal of this packaging material is taken care of. Okay. The films which are used in modified atmosphere packaging, it may be polymeric film like LDP, SDP, polypropylene, OPP, metallized polyester, EVA, PVC. It may be perforated or micro perforated. Even edible films like biopolymers, emulsions, laminates, etc. or smart packaging film material like temperature responsive ethylene or absorbers, etc. or antimicrobial like wasabi based polymers. So that different polymers can be used or films can be used in modified atmosphere. Then function of modified atmosphere gases in the preservation of the commodity. Okay, that is the gases that are applied in modified atmosphere. We have seen earlier, they are O2, CO2 and nitrogen. So nitrogen has no specific preservation effect, but it functions mainly as a filler gas to avoid the collapse of the real collapse that takes place when the CO2 dissolves in the packet. So that is taken care of by nitrogen. The carbon dioxide, because of its antimicrobial activity, is the most important component in applied gas mixtures. Okay. The different proposed mechanisms of antimicrobial action of carbon dioxide are lowering the pH of the food, cellular penetration followed by a decrease in the cytoplasmic pH of the cell, specific action on cytoplasmic enzymes, specific action on biological membranes. So the gas or product volume ratio and permeability of the applied film for oxygen and carbon dioxide will influence the amount of dissolved carbon dioxide and thus its microbial inhibition properties. The effect of modified atmosphere package on nutritional quality is concerned. It may have some effect on the phenolic compounds, vitamin C, carotenoids, etc. there is a decrease in almost all phenolic compounds like anthocyanins, flavonoids in both skin and pulp grapes of berries in CO2 enriched atmosphere was noted due to the aerobasis. So, anaerobasis can lead to unwanted browning and loss of anthocyanin, and this anaerobasis can also lead to decrease in the phenolic compounds in the grapes. It was particularly observed. Then low oxygen and high carbon dioxide enhances retention of ascorbates, but in fresh cut produce with high carbon dioxide causes degradation of vitamin C. Lower oxygen and enhanced carbon dioxide reduce losses of provitamin A. However, no change in the RTE oranges after 11 days storage at 4 degrees Celsius in modified atmosphere packages was observed. The composition was 19% O2 and 5% CO2 and 3% O2 and 25% CO2. These were various in these ranges. This was studied and no change was observed. Then equilibrium humidity packaging, very important aspect while going for modified atmosphere packaging or such other active packaging and so on, whatever you do. So, what happens, that is the fresh the produce respiring in hermetically sealed packs, it leads to decreased O2 and increased CO2 and water. That is when the material is respiring inside the package, depending upon the barrier properties. There will be, because inside the O2 is consumed by the commodity, so oxygen level will decrease, okay, and CO2 level will increase, and so the water vapor. All right. So, the increased CO2 can have inhibitory effect on microbes. However, decreased oxygen can increase risk of anaerobic growth of microorganisms like fungi and some bacteria. Similarly, reduced water can lead to shriveling and drying of the fresh produce. So, inside we need that a proper gaseous composition is maintained. At the same time, the material should not shrivel, it should not dry. Means that inside and outside the humidity is made same. That is, if the produce items respiratory characteristics are properly matched to film permeability value, then a beneficial equilibrium modified atmosphere, which is known as EMA, where high O2 and high moisture can be passively established. And this is the concept of equilibrium humidity packaging. That is, the humidity inside the packaging environment head space and outside the packaging environment in the room where the pack is maintained, it is balanced or equilibrized. Otherwise, if there is a disbalance, then the moisture will condense, which is going out water vapor, it will condense, and it will condense. So, it will act as a vector for microbial growth, that you can see here in this experiment to be conducted in our laboratory, and you see here that in an improperly designed modified atmosphere package, you see that there is a condensation of moisture, okay, the causes accumulation, and therefore, this where the moisture is condensed, this acts as a vector for microbial fungal growth, etc. Where modified atmosphere is maintained properly, then there is a, that is the gaseous composition, either scavengers, etc., they are properly used. Then, so, study of the transpiration, rate of transpiration TR, helps to quantify even the rate of water evaporation from the fruit surface, and also it helps to determine the water vapor transmission rate required for the packaging of the fruit. That is, depending upon the particular fruit, one can calculate what will be the WTR requirement in the film that is used for MAP, and therefore, what will be the even scavengers, etc., scrubbers, etc., if required in the active modified atmosphere, that can be calculated and used, that we discussed in the earlier classes. So, basically, here equilibrium humidity packaging can be used to extend the shelf life of fruits and vegetables considerably. Okay. If the equilibrium humidity is not maintained inside, the water vapor will condense on the walls of the package, and it will enhance the bacterial growth. So, to design ESP of the fruit and vegetable, it is essential to have the information about the rate of water evaporation from produce surface, and so it should be balanced with the water vapor transmission rate of the packaging material. The rate of the water evaporation from the produce of the surface should be balanced with the water vapor transmission rate of the packaging film, and the ESP, equilibrium humidity packaging, should be maintained, so that there is no condensation of water inside. So, the equilibrium modified atmospheres or equilibrium humidity is attained. These are influenced by, of course, proper respiration rate, film permeability, and pack volume, surface area, and weight, etc. So, humidity regulation techniques include packaging material like that is perforated films. You can see strawberry here packed in film with 40 micron perforations, that is, it allows the movement of gases from in and out, etc. Even and then individual shrink wrapping or enhanced permeable films, etc. or moisture absorber, like we discussed in active packaging or active MAP, desiccators, humidity regulating trays or pads, etc. Okay, they are used different types, and then accordingly these are. So, by this way, adapting a suitable way, that is the humidity is equalized inside and outside. Okay, that is. So, finally, I will say that yes, modified atmosphere technique is again very important in extending the shelf life of fruits and vegetables. Okay, it modified atmosphere can be generated actively, it can be active modified atmosphere storage or passive, or even nitrogen flushing or other gas flushing, vacuum packaging, etc. Okay. This MAP of the produce can increase the shelf life. However, it might increase the cost and additional facilities needed during its functioning. The nutritional components, etc., generally it will remain intact. However, there might be some little change depending upon how the conditions has been maintained. Okay. But it is a good concept to increase the shelf life storage, and in fact, in the next class we will discuss that control atmosphere storage. So, basically that is the control atmosphere, where that is the proper combination, the not only control, it is modified and then controlled. So, we have discussed how it is modified, and that it is very important that the composition is first modified and then it should be properly controlled and maintained at that level. So, that we will take up separately. These are the references used in this lecture. Yes, thank you very much.